Welcome to Session 18, Radicals, Rational Exponents, and Scientific Notation. Today you will simplify radicals using perfect power factors. Connect radicals with rational exponents, and calculate with scientific notation and estimate magnitude. Watch the structure, not just the arithmetic, because each move must preserve the meaning of the problem. The visual gives us the central idea. Moving the decimal left to create a coefficient between 1 and 10 produces a positive exponent for a large number. Moving it right for a small decimal produces a negative exponent. The number of places moved must match the exponent magnitude. Use this first move. For a radical, factor the radicand and extract perfect powers. Then, for rational exponents, use the denominator as root and numerator as power. Worked example. Simplify a radical. Simplify the square root of 200. Step 1. Factor out the largest perfect square. 200 equals 100 times 2. Step 2. Then the square root of 200 equals the square root of 100 the square root of 2. Step 3. Since the square root of 100 equals 10, the simplified result is 10 the square root of 2. The final answer is 10 the square root of 2. Check that it satisfies the original conditions and carries the correct units. Now it is your turn. Simplify the square root of 75. Pause, write each algebra step, and use the next 6 seconds to finish your solution. Here is the modeled solution. The answer is 5 the square root of 3. Factor 75 as 25 times 3. Verify it against the exact wording before moving on. Session 18 recap. For a radical, factor the radicand and extract perfect powers. Next, for rational exponents, use the denominator as root and numerator as power. Then, for scientific notation products or quotients, operate on coefficients and powers separately. Finally, normalize the coefficient and estimate the final order of magnitude. A complete solution shows the reasoning, checks the result, and states what the answer means.